Okay, so the first thing you should do is write down the average value of a function. Write down that definition we went over yesterday, the average value of a function. Okay. Write it down. Like at the top of your paper in that open space at the top. All right, so what was that? What was that definition? The average value of a function.
The 1 over b minus a.
1 over b minus a times the integral from a to b of f of x dx, right? So write that down. That's what we did yesterday. Yeah. So, because today we're going to do the same thing, we're going to do the exact same thing today. Okay? Example 1 says, find the average of f of x between x equals 0 and x equals 12. The portion of the circle of the curve between x equals 3 and x equals 9 is a half circle. So we're not given a function, we're just given a graph of a function. Right? So how do we go about finding the integral if we're given the graph? What do we have to do? We find the areas. Okay? And conveniently enough, we can break this guy up into something or other that looks like a rectangle maybe, something that looks like a rectangle with a circle cut out, and then something that looks like a triangle. So the average value will equal 1 over, now we're going from 0 to 12, so a to b, so 12 minus 0 times the integral from 0 to 12 of f of x dx. So we have 1/12 times. Now for the integral, again, we just got to go back to our roots. We've got to find the areas. So how high up is this guy right here? What information we have that might help us figure out how high it is? We've got a circle part, and the circle part has a radius, right? This would be the radius of that circle. How wide is this? So then how tall is this? So this must be 3. So that first shape is a square, actually, with an area of 3 times 3. Plus. Then we've got a rectangle. We've got a rectangle with a semicircle being cut out of it. So the rectangle would have an area of 3 by 6. But then we're subtracting out that half circle, so that's half of pi, radius is 3, so half of pi times 3 squared. All right, so there's my second shape, plus that triangle, which is a half times a base of 3 and a height of 3. 3 times 3. And so we have 1/12 of, now if we multiply all this stuff out, we're really, really careful typing the calculator, we get 17.36283 as as that integral. We want 1/12 of that, and so we get our final answer of 1.447. The average value of that function on the interval from 0 to 12 is 1.447. Which again, if you think about the definition of the average, what that really means, if you think of all of this as ice, and we've got some solid container containing from 0 to 12, and we let it all melt, then that rectangle that's formed would come across, maybe right there at 1.47, right? And so that's really what we're finding. We're finding that on average the function is at 1.447, which means it's above that just as often as it's below it or equal to it. So given a graph, right, not a function, what if we give it a table? Well, we can't get the exact average value of the function because we can't integrate this and get an exact area because there's too much unknown stuff. Between 0 and 1, there's an infinite number of possibilities. Okay, so all we can do is approximate the average value using a Riemann sum. We saw this on yesterday's open response problem, right, on portfolio number 1, where we wanted to find the average temperature of the water, and we used the left Riemann sum to approximate that average. We do the same thing here. It says using a right Riemann sum using 3 subintervals. Find the approximate average of the function. So we want 1 over Now our interval here is from 0 to 6. So 6 minus 0 times the integral from 0 to 6 of our function f of x dx. Now again, we can't get the exact integral, right? So I'm going to actually put, we can't get the exact average. Notice the average is equal to this. And this is going to be approximately 1/6 times, and now we'll do a right Riemann sum. Okay, so we're going to use a right Riemann sum with 3 subintervals. So how wide is each interval going to be? It's going to be 2, right? So we go from 0 to 6, so that's 6 divided by 3, so each one is 2. So 2, 2, and 2. So that's our delta x, 2. Now for a right Riemann sum, we pick the rightmost value. So for the first rectangle, we're going to choose 7.4. Next rectangle, 5.5. And the last rectangle, 4.4. And so we work all this out, we get 1/6 times 34.6. And 1/6 34.6 is equal to 5.767. So the average value of this function, given this data table, is approximately 5.767. Now, assuming that this function is always doing what it's doing here, based on this table, would you say this function is increasing or decreasing? It's decreasing. Okay, so it's going down. The f of x is decreasing as x increases. So is the right Riemann sum going to give us an overestimate or an underestimate? Okay, so if we've got a decreasing function, right gives us an underestimate. Right? Okay. And the same applies for the average. So we know the average is actually more than this. Right? Just like yesterday on the temperature problem. All right. If you take a look at the assignment, believe it or not, first 2 problems coincide really well with the first example. The next 2, number 3 and 4, coincide really well with the second example. And then from there on, it's what we were doing yesterday and the day before. It's fundamental thermocalculus. Okay. One couple things that I caught problems with in third period as kind of holdups. First off, what's a root? Okay, so what's another word for the root? X-intercept, right? Or 0. Okay, how do we find the root of a function? Let it equal to 0. Fantastic. Okay. How do we find, so look at number 6 says use the fundamental theorem of calculus to find the area between x equals 1 and x equals 5, and under the line, I'm going to underline this, line that is the tangent to f of x equals s squared x equals 3. How do we find the line that is tangent to a function? Okay, well that doesn't give us the line though, that gives us the slope of that line. So how do we find the line, the actual equation for a line tangent to another line? We start writing y minus y1 equals m times x minus x1. Right? The derivative gives us the slope. We want to find it at a specific point. We can get a y value and an x value. We get our equation for our line. Okay? All right. So that is that. You've got the remainder of the period to work, so about 40 minutes.